to another question, which is which of the following, which of the sets given given below may may represent represent the the magnitude of of three vectors adding to zero adding to 0. So our options are 2, 4, 8, which is second one is 4, 8, 16. The third one is 1, 2, 1, and the fourth one is zero point 0.5, 2, and 1. So if you watch my previous video, this is a very simple question, and I can tell you the answer just by looking at the question, which is going to be C. So why is it going to be C? So it's going to be C because of the following reason. So let's just look at each of the fours, so which is 4, 2, 4, and 8. And if you remember in the previous video, we talked about if so if you haven't watched the previous video, let's write the statement just for you. So I will write this in a summary form. So for okay, so in order for zero magnitude in some case, so in some case, not every case, in some case, the sum of magnitude of other vectors other than largest vector in terms of magnitude must be greater or equal to the magnitude of largest vector. So so the largest vector, so this is not summarized form, but this is actually the definition. I just wrote it in full way. In the other video I also wrote this in a much more shorter way. If you want to check it out, you can obviously check that out, and this is going to be a quick video since I have already explained this kind of question. So let's look at 2, 4, and 8. So if I look over here, I obviously see the sum is gonna be 6, which is less than 8. So since this is less than 8, 0 is not possible. So for not possible. And for the second case, which is 4, 8, 16, so 4, 8, 16, just look at the other vectors except the largest one. It will be 4 plus 8, so it will be 12, and 16 is greater than 12. 16 is greater than 12, so this is also not possible. Obviously, if you want a much more logical explanation, you can watch my previous video. And the third one, which is 1, 2, and 1, 2, 1. So 1, 2, 1. The smallest ones, so this one and this one, gives you 2. So when adding them, and this one, so let's make it another color since that might be confusing. So this one is also 2, which is equal. So in this case, it is possible for there to be a resultant of 0 magnitude in some case. And finally, in the last one, which is 0.5, 2, and 1, so 0.5, 2, and 1, let's take the smallest one, which is 0 0.5 and 1, which will give us 1.5, and which is still smaller than 2. So point also it matters, so this is also not possible. So in a basic sense, to understand how it is not possible, you can think it of like this. So since if you were to add, or if you were to add this vector and this vector so that you get the maximum possible value, it will obviously be 1.5. And if these vectors were exactly in opposite direction, so if it like this and this will be 1.5. So this will be 1.5, even though this is the maximum value that is possible from these two smallest values, and the other value is going to be 2. So even if they are acting exactly opposite from each other, there is always going to be a case where this vector is going to dominate, which means there will not be any case where there will be 0. But in this case, the maximum is 2. So if they are exactly in opposite direction and the two smaller vectors leads to the resultant having a magnitude of 2, the net resultant leads to being 0. That's why this is possible, which means, and this is our answer in this case. So that's pretty much it for today's video. This was a short one. So in the next video, we are gonna do another question. Till then, bye bye.